All right, the last built-in data structure we're going to talk about are dictionaries. And dictionaries are used quite a bit throughout Python. And there are some similarities to lists. For example, they are mutable. They are dynamic, which means they can grow and they can shrink. So unlike tuples that are immutable, dictionaries are mutable. We can contain nested information within a dictionary. So we could have a list as an element in a dictionary. We could have another dictionary within a dictionary. But then there are some differences. For example, when we create a dictionary, what we actually use is we use the curly braces and we supply a key and a value. For example, let's just create a dictionary. I'm going to call this D, and we're going to have first name, right? So this is the key, right? This will be how we can look up information within our dictionary. And then we have some value, right? For in this case, I have my first name. And then if we want to add more elements, we can definitely do that. We could say last name and then supply my last name, right? So here's a dictionary. Oh, I got to complete my string. We have a dictionary here, and we can go ahead and we can verify type D, and there's our dictionary. Now, like we said, it is mutable, right? So we could always go ahead and take D, and let's say I want to add a new element, right? So what I could do is go ahead and I could add alma mater, right? Which for me was North Dakota State University, so I could do NDSU. And now when we go ahead and take a look at our dictionary, we've added a third element, right? And we can continue to add those. Add or even delete existing keys, key and key value pairs. So now whenever we want to look up a certain item in a dictionary, we can use the exact same bracket notation that we did with lists and tuples. The only difference is instead of doing the index location right here, we would say like I want to get the first item. We don't do that. We actually look it up based off of the key, right? So I want to look up first name. So the reason for this is dictionaries have a different method for actually storing the information, and the keys are implemented as what we call like a hash table lookup. And that may be something you've never heard of before, and that's perfectly fine, but just realize that when certain items are converted into like a hash lookup procedure within a computer, it makes them extremely efficient. So if you have a very large list versus a very large dictionary, it is way faster to look up information within a dictionary because we're using a hash lookup procedure than if we are looking something up in a list. Within a list, we have to iterate over every single element until we find the one we're looking for, where a dictionary has a different procedure for actually looking up information, and it's actually very beneficial. All right, so you saw in the lesson that the operators and some of the indexing procedures within dictionaries, they do have a lot of similarities to what we saw with lists and also tuples, so we're not going to necessarily cover those. There are a few additional types of operations we can do within dictionaries. So dictionaries have several different methods that are attached to them. For example, we could always get the items within our dictionary by doing the dictionary.items, right? And it'll supply the different information. Now, if you look at this, you'll see that we actually have a list here, and we have the items for the key and the value within the dictionary are stored in these tuples. Now we can always look at the keys that we have. Whoops. And that'll supply us the different keys that exist within our dictionary, and we can also look at the different values that we have within our dictionary. All right, so let's check out this knowledge check for dictionaries. And this knowledge check says, imagine you need a way to quickly determine a company's CEO given the company name. You could use a dictionary such that CEOs and then the company name provides the CEO. or the CEO's name. So let's do this, and we're going to start by creating a dictionary that's just called CEOs, and it's going to contain 2 companies and their CEOs to begin with. All right, so we can go ahead and we can say we have Apple, and that's going to be Tim Cook, and then we've got Microsoft, and that's going to be Satya Nadella. All right, so we now have our CEOs. We can take a look at that dictionary, and we see, in fact, we have the curly braces. It is. We can just verify that it is a dictionary if we wanted to. Okay. All right, so let's go ahead, and it says, now add Bob Iger as the CEO of Disney. Right. So actually, before we do that, we can go ahead and we can show that, hey, look, let's say I wanted to get Apple's CEO out of this. We could index for that. We get Tim Cook. If we wanted to find, oh, you know what? I have Apple. Let's make this uppercase so it's correct. And then we have Microsoft, and we get Microsoft CEO. But now it says, now add Bob Iger as the CEO of Disney. So Bob Iger used to be the CEO of Disney. So we're going to go ahead. We're going to assign a new key value pair within our CEO. So here we are creating the new element here. We're going to assign the value of Bob Iger. And so now if we look at our CEOs, we should have 3 different companies in here in their CEOs. Okay, so now you realize that Bob Iger is no longer the CEO of Disney. Rather, it is Bob Chapek. And we want to update this Disney CEO to reflect this change, right? So the way that we can do that is we can always index for Disney, right? And we would get Bob Iger right now, but we want to change, mutate, alter that value to be Bob. All right, so now when we look at our CEOs, we should have an updated dictionary. We got Apple, Microsoft, and the updated Disney CEO.